Hello, everyone. Today we are going to talk about ISSI's Octal Memory Solutions. JEDEC has standardized and named the Octal interface as Expanded Serial Peripheral Interface, commonly known as xSPI. It provides low signal count and an extremely high data throughput of up to 400 megabytes per second. There is limited backward compatibility with legacy SPI devices. Today, the Octal or xSPI interface is supported by all major SoC makers, thus enabling the ecosystem for faster adoption of Octal interface in the industry. The same Octal interface can be applied to a flash, a RAM, or another peripheral device. Currently, a wide range of applications across automotive, IoT, embedded systems, computing, and other industries are embracing the Octal interface. The Octal or xSPI is a low pin count interface. As the name Octal suggests, there are 8 I/O pins to communicate between the host processor and the Octal memory or peripheral device. The command, address, and data are sent over these 8 I/O bus. Other than that, there is a clock pin, a chip select bar, and a data strobe pin, which is an input to the host processor so that it can properly sample the incoming read data at high frequency on both edges of the clock. ISSI is pleased to introduce the Octal family of memory solutions, which consists of Octal Flash, Octal RAM, and Octal MCP, which is Octal Flash and Octal RAM in one package. All the Octal family products share a common footprint, the same 8x6mm 24-ball BGA package arranged in a 5x5 array. This package is compatible to SPI or Quad SPI memory device, which is also utilizing the same package. In addition, all the Octal family products, the Flash, the RAM, and the MCP, are automotive grade and support -40 Celsius to 125 degrees Celsius. Here is a top view of the 24-ball BGA package. As you notice, they all have the same common footprint, which includes the bus signals, VCC, and the VSS pins. Different types of architectures exist between the host and the memories. It depends on the application. Sometimes board space is most critical. At other times, it could be performance or pin count or PCB cost, which is most important to the application. Here we show you how Octal memory solutions can help system designers achieve high performance with low pin count, small footprint, and low PCB cost. It could be an Octal Flash and an Octal RAM, both connected to the Octal bus from the host processor. Or it could be an Octal MCP, which can reduce pin count even further. Octal MCPs would be a great fit for wearable applications. We also offer Octal Flash and Octal RAM as known good die for SoC makers to co-package as a system in package. Here is a summary of our Octal memory solutions. As far as Octal Flash is concerned, we are sampling the 128 megabit and 256 megabit Octal Flash. Soon, we would be rolling out lower density Octal Flash products like the 32 megabit and 64 megabit, followed by high density like the 512 megabit and 1 gigabit Octal Flash. We are in production with our 128 megabit and 256 megabit Octal RAM, and working on lower density options like 32 megabit and 64 megabit Octal RAM. Regarding the Octal MCP, we have picked the sweet spot in terms of densities. Various combinations of 128 megabit and 256 megabit Octal Flash and Octal RAM. Please feel free to reach out to us for samples of Octal Flash, Octal RAM, and Octal MCP. Now we want to dig a little bit deeper on Octal and xSPI Flash. Let's look at the evolution of serial NOR Flash. The serial NOR flash industry started off with a by-one interface running at maximum speed of 166 megahertz and a maximum bandwidth of approximately 20 megabytes per second. This evolved to Quad SPI NOR flash, which supports a by-four interface and can thus provide 4 times the bandwidth of an SPI device while running at the same maximum speed of 166 megahertz. In order to reach higher read bandwidths, many customers read from 2 Quad SPIs at the same time from 2 separate devices. Twin Quad SPI addressed this market by placing 2 Quad SPI dies in a single package and allowed the host to read from 2 separate by-4 buses. The bandwidth simply doubled that of a Quad SPI. JEDEC eventually saw the need to formalize a new set of commands called xSPI to further increase the real bandwidth. The new xSPI protocol is often referred to as Octal Flash and is the official by-8 serial flash protocol. The maximum speed of the xSPI flash can be 200 megahertz, which gives a bandwidth of 400 megabytes per second, which is almost 5 times the bandwidth of a Quad SPI NOR flash. The command, address, and data can communicate between the host and the xSPI flash over an 8-bit I/O bus. Here is a summary of the ISSI Octal Flash. Our xSPI flash will cover a wide range of densities, all the way from 32 megabit to 2 gigabit, available in both 1.8 and 3.3 volt. Like other ISSI serial NOR flash products, our Octal Flash will also be supporting automotive grade from temperatures of -40 to 125 C. Here is our Octal Flash roadmap. As mentioned earlier, we are currently sampling our 128 megabit and 256 megabit Octal Flash. In the next couple of months, we will start sampling our low density Octal Flash, 32 megabit and 64 megabit. In Q1 of next year, we will be sampling our 512 megabit Octal Flash and 1 gigabit Octal Flash. In parallel, we are developing a 50 nanometer based 512 megabit Octal Flash solution. We expect to sample that device towards late 2021 timeframe. That will be followed by a 1 gigabit and 2 gigabit Octal Flash on 50 nanometer. We will support our customers with a broad range of Octal Flash products ranging from 32 megabit all the way up to 2 gigabit. Like all our other ISSI products, each and every part on the roadmap will be supported in automotive grade, supporting -40 to 125 C for plus 10 years. In addition to Octal Flash xSPI, ISSI is working on a family of products called Quad DDR SPI. This allows quad I/O functionality to run at speeds up to 200 megahertz DDR and allows the throughput to reach speeds of 200 megabytes per second. This makes migration of QPI mode Quad SPI flash to Quad DDR SPI simplified. Performance throughput is more than doubled by moving to Quad DDR SPI. Here we contrast the footprint of Quad SPI versus the new Quad DDR SPI footprint. As you can see, the footprint is almost identical. Only minor additions of VSS and VCC pins are required and boxed in green. These items in blue are additional features that can be taken advantage of. These include a dedicated write protect pin, error indicators, and a DQS pin for more reliable DDR operation. Next, we are going to talk about Octal RAM offering. ISSI offers an extensive portfolio of Octal RAM products that complement our Octal Flash product family. Octal RAM is based on DRAM technology with hidden refresh and supports Octal xSPI protocol. Octal RAM provides a throughput of 400 megabytes per second at 1.8 volts and a throughput of 266 megabytes per second at 3 volts. It is a low pin count solution and is offered in a 24-ball VGA package. Currently, we are sampling up production of 128 megabit and 256 meg densities. These products are offered in 1.8 volt and 3.3 volt. The 256 meg product can support a temperature range of -40 to 105 C, and the 128 meg can support a temperature range of -40 to 125 C. One additional option for the 128 meg density is the availability of an on-chip ECC version of this product. Here is the Octal RAM roadmap. One of the differences from ISSI is the long-term product support strategy. As you can see from the roadmap, we are providing support until 2030 and with the intention to support these products even longer. As mentioned, we are now sampling the 128 megabit and 256 megabit product options. Our 64 megabit product is in the late stages of development, and we expect to provide samples in the next few weeks. Now for Octal MCP. In addition to the Octal Flash and Octal RAM, ISSI also offers an Octal MCP solution, an Octal Flash and an Octal RAM in one package. Each Octal MCP consists of a 128 megabit or a 256 megabit Octal RAM and a 256 meg or 512 megabit Octal Flash. The possible combination for MCP would be a 128 meg Octal RAM and a 256 megabit Octal Flash, or a 256 megabit Octal RAM and a 256 megabit Octal Flash, or a 256 megabit Octal RAM and a 512 megabit Octal Flash. Currently, we are sampling the 256 megabit Octal RAM and 256 meg Octal Flash MCP. We thank you for listening, and we wish you luck on your next journey of design.